Hi, and welcome to your Star Spectra Gizmo. So my dashboard will look a little bit different than yours because I have the teacher's dashboard while you have the student dashboard. Hopefully, you are seeing the Star Spectra Gizmo ready to launch. If you are not for some reason, please come up to the Find Gizmo. You are going to type in Star Spectra, and this is the gizmo that you want to launch. Okay, so let's get started. For the prior knowledge questions, I would really like for you to pause me and answer them as best you can, and then return so that we can work through the warm-up and I can introduce you to activity A. All right, so hopefully you've worked through that prior knowledge. If you hadn't, please pause, go do that, and then return. So for the gizmo warm-up, it tells us that the interior of a star produces a continuous spectrum of light, like a rainbow. Cooler gases in the outer layers of the star absorb certain wavelengths of light, causing dark lines to appear in the spectrum. The resulting absorption spectrum can tell astronomers a great deal about the star. So on the Star Spectra gizmo, turn on Show Labels, select star 1 to see its absorption spectrum. So I'm going to turn on the show labels up here, and I can see that this little blue guy here is going to be star 1. And when I click on it, I see its spectrum. So the first question asks us, how many questions do we see in the spectrum? Or how many lines, do we see in the spectrum? So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we see 10 lines in the spectrum. Next, we're asked to drag the hydrogen spectrum so that it lines up with the edges of star 1 spectrum. So please notice that the hydrogen spectrum is above the hydrogen label, the helium spectrum is above the helium label, the sodium spectrum is above the sodium label. You get the hint? All right, so let's take hydrogen down and line it up. Ooh, we got some matches. So it looks like we have 1, 2, 3, 4 lines from our hydrogen spectrum that we are also seeing on our star number 1 spectrum. So yes, we do have some lines that line up. Then it tells us to drag the helium spectrum next to the star spectrum, and do we have matches there? So let's take a look. I'm going to put hydrogen back and bring helium down. Oh, absolutely, we have some more matches. It looks like we've got 1, 2, 3, 4, 5, 6 that line up on helium, and we have the 4 that line up on hydrogen, so we have all 10 lines accounted for. So yes, some of the lines on helium do match, and then it says try out the other available spectra. Do any of the others have lines that match? Well, we counted them, so we know that the answer is going to be no. Okay, so there's sodium does not line up. There's magnesium does not line up. I know that there's one line, it's about the fourth or third one, the third one in on magnesium, that it looks as though it might line up. But when we look at how broad it is, that does not match our star spectrum. Let's bring calcium down. Oh, no way. No matches there. And let's finally look at iron. I think we can tell right away that that's not going to be a match. No. Okay, so do any of the other star spectra available have lines that match? The answer is no. So then which elements have contributed to the spectra of star number 1? Well, that would be hydrogen and helium. So let's open to activity A. And the introduction tells us that in the 19th century, Harvard astronomer Edward Pickering wanted to sort and catalog the thousands of star spectra that had been collected by the Harvard Observatory. He hired several women to do the work, paying them 25 cents a day. The most prominent of these women was Annie Jump Cannon, who devised the classification system still used today. And you'll learn more about Annie Jump Cannon when we watch Cosmos Season 1, Episode 8. And we can see that Annie Jump Cannon's classification system gives us a class, a color, the prominent spectral lines that we need to be looking for, and then the approximate surface temperature. So let's drop down to our first set of instructions, and we are told to classify. Use the gizmo to find the elements that are present in the spectra of stars 1 through 4. Remember to check both the neutral spectra and the ionic spectra. Then use the table above to classify each star and describe its surface temperature. Note, a star spectrum may not display lines of all the elements typical of its spectral class. Well, let's do star number 1 because we've already done that one. So star number 1, what color is it? You should be able to see right there on the screen. Star number 1 is blue, so fill blue in for color. We know from what we just did in the Gizmo warm-up that our elements are going to be hydrogen and helium. So now I should be able to figure out which spectral class that is. Well, if I look up on my exploration sheet, I'll see that the only two stars that are blue in color can either be O or B. So O-class stars have ionized helium and hydrogen. We didn't look at ionized helium. We had neutral helium. So that should tell me right away it's not a class O. So let me move down to class B. So class B stars can be blue or white. Good. They have neutral helium and hydrogen. Bingo, we found it. So star number 1 is a B class star, and its temperature is going to be between 11,000 and 25,000 Kelvin. So I would like for you to complete stars 2, 3, and 4. Please be sure that you are accounting for all of the lines on stars 2, 3, and 4. So if you don't find it in this neutral spectra, you'll need to flip over to the ionic spectra. And again, I'm just doing that up here. All right, so work through stars 2, 3, and 4 on your own, and then we will regroup and we'll take a look at stars 5 through 10.